How do you integrate 3D printed robot parts with electronics? Imagine building a robot where the mechanical parts and electronic brains work seamlessly together. That's what integrating 3D printed robot parts with electronics is all about. When you design a robot, you start by creating the physical structure using a 3D printer. But the real magic happens when you add the electronic components that make the robot move, sense, and respond. First, you need to design your 3D printed parts with features that make electronics easy to install. Think about adding channels or grooves inside the parts to run wires neatly. You can also include slots or holes for mounting circuit boards, sensors, or connectors. Making these features during the design phase saves time and keeps everything organized. For example, you might add a small cavity to hold a microcontroller or a slot for a sensor. This way, when you print the parts, they are ready for electronics to be installed without extra modifications. Material choice is important too. Most 3D printing plastics like polylactic acid or acrylonitrile butadiene styrene are insulating, which helps prevent short circuits. But if you want to embed electrical paths, you can use special conductive inks or pastes. These can be printed onto the surface of the parts after printing or even during the printing process if you have multi-material printers. This allows you to create flexible, stretchable circuits directly on soft or flexible parts, which is especially useful in soft robotics. When working with rigid robots, you typically mount components like microcontrollers, sensors, and wiring inside or onto the printed housing. It's best to plan 4 access points for connectors and to include strain relief for wires. Using standard electronic modules and connectors makes maintenance easier and keeps the wiring neat. For example, you might design a chassis with built-in clips or snap-fit features to hold circuit boards securely. Surface treatment can help improve adhesion of electronic components. Techniques like plasma treatment or applying special adhesives can make surfaces more receptive to conductive inks or glue. In some advanced cases, you can even bond printed electronic layers directly onto elastomeric or flexible parts for better durability. Embedding sensors during the printing process is another option. This involves printing the sensor as part of the structure or inserting it layer by layer during printing. It reduces assembly steps and creates a more integrated system. Practical projects include soft robotic hands with embedded circuits that sense pressure or movement, or fully 3D printed soft robots with integrated fluidic and electronic control systems. For rigid robots, designing the printed chassis with channels and mounts helps keep wires organized and components secure. In summary, to connect 3D printed robot parts with electronics, you start by designing features for easy mounting and wiring. Choose materials that suit your needs. Consider multi-material printing for embedded circuits, treat surfaces for better adhesion, and plan wiring routes carefully. Embedding sensors during printing can streamline the process even more. These steps help you build robots that combine customized mechanical parts with reliable electronics, making prototyping faster and more efficient.